Everyone, so welcome, and today we are going to do the review packet for the Unit 1 Topic 4 formative assessment. So a couple things about this formative assessment: you will not be allowed to use a calculator, and you will be given the quadratic formula. So for the first problem, we need to partially decompose each of the fractions here. So the first thing that we want to do is to factor this. I noticed that 2x squared and negative x has a GCF, a greatest common factor of an x. So I can pull that out. So if I divide 2x squared by x, I get 2x. And if I divide negative x by x, I get negative 1. So the goal is we need to split this up into two separate fractions. Notice how your denominator has two factors. The first one is x, and the second one is 2x minus 1. So for our first fraction, we'll call it a over x plus b over 2x minus 1. So the goal is to find the least common multiple. So the least common multiple is really just x times 2x minus 1. So essentially, for our first fraction here, a, we need to multiply that by 2x minus 1. So we need to multiply a by 2x minus 1. And we need to multiply b by... So we need to multiply b by x. So there are two methods to solve this out. The first method that we can do is we can just set up a system of equations. So we can work this out like so. We can say 8x minus 3 is equal to a times 2x, which is 2ax, minus 1 times a, which is negative a, and then plus bx. So I kind of want to move these guys around a little bit. We have 8x minus 3 is just 2ax plus bx minus a. So notice a couple things here. 8 is really just 2a plus b. So we say 2a plus b is equal to 8. And negative 3 is just equal to negative a. So this problem is kind of silly. We have something like that. So therefore, okay, so if negative a is equal to negative 3, right, you can just do, well, negative a is equal to negative 3, divide both sides by negative 1. A is positive 3. So if we use our second equation, we get 2a plus b is equal to 8. Since a is just equal to 3, right, 2 times 3 plus b is 8. 2 times 3 is just 6. 6 plus b is equal to 8. So b is obviously just 2, because 8 minus 6 is 2. So once you got that, make sure that you plug a back in. So it would just be 3 over x plus 2 over 2x minus 1. Box our answer, and we are done. So we could have done it like that. Another way we could have done it was to offset it. So another way that we could have done it was to say, like, let x equals to 0. Because if x is equal to 0, the b goes away. So it would just be like 8 times 0 minus 3 is equal to a times negative 1 plus 0. So this is just negative 3 is equal to negative a. And the same thing, a is equal to 3. Or we could just set that x is equal to 1/2. You plug it in, the a goes away. So you have 8 times 1/2 minus 3 is equal to 1/2 b. So we have 4 minus 3 is 1/2 b, right? So 1 is equal to 1/2 b. Multiply both sides by 2, and b is equal to 2. So you could have also offset and got the same answer. So I'm just going to erase this a little bit here. So we have some space for the next piece. So I know some of you guys like to offset. I think that's the easier way to go. So on the formative, you can either offset or you can solve it normally. So I'll do the next one by offsetting it first. So for this one, we want to factor the denominator. So we're looking for two numbers that multiply to get -2 that adds up to 1. So there's only two options. It's either 2 and 1. And so the 2 has to be positive because 2 minus 1 is positive 1. And that's the one we want. So we set this up. This is going to be a over x plus 2 plus b over x minus 1. So by now you should know that, okay, the LCM should be x plus 2 times x minus 1. Right, that's the LCM. X plus 2 times x minus 1. Right? So essentially, the numerator will become, so therefore, 2x plus 1 is equal to a. Make sure you multiply a by x minus 1 and not x plus 2. Right? You want to multiply it by that one. Right? Shoot. I need to rewrite this. So this is going to be a over x plus 2, right? Plus b over x minus 1. So we need to multiply b not by x minus 1, but by x plus 2. All right. So we could set up the system of equations, but this time let's offset it. So let's let x be equal to, say, 1. Because if x was 1, right, this goes away. A goes away. So it'll be 2 times 1 plus 1 is equal to a times 1 minus 1. That goes away because 1 minus 1 is 0. Plus b times 1 plus 2. So 2 times 1 is 2. 2 plus 1 is 3. And this one is pretty easy. 3 is equal to 3b. Divide both sides by 3. B is 1. So that's the first one. For the second one, this time let's let x be equal to -2. Because if x was -2, right, the b goes away. So it becomes 2 times -2 plus 1 is equal to a times -2 minus 1 plus b times -2 plus 2 goes away. Because -2 plus 2 is 0. So now what do we have here? We have -4 plus 1 is equal to -3a. Okay, that's pretty straightforward here. That's just -3 is equal to -3a, my bad. Divide both sides by -3. A is 1. Make sure that once you're done, you go back and you write out what the answer is. The answer, right, should be 1 over x plus 2 plus 1 over x minus 1. That is the partial decomposition. So we could have also done that using the method before, but I like to offset. So if you prefer the other method, the traditional method, we can do it again. It's a little bit longer, so you just need to work it out. So we have 2x plus 1 is equal to ax minus a. So you distribute out the a. You distribute out the b. So plus bx plus 2b. All right? So a couple things here. I notice 2 must be a plus b. Right? So we say like a plus b is equal to 2. Fix the handwriting here. A plus b is equal to 2. And negative a plus 2b is equal to 1. Negative a plus 2b is equal to 1. And this one is very straightforward. We can just add these up. If I add these up, the a goes away. So 3b is equal to 3. Divide both sides by 3. B is equal to 1. Well, we know that a plus b is 2. So b was 1. A is just 2 minus 1. So a is equal to 1. And then you plug it back in, and you get the exact same answer as before. 1 over x plus 2 plus 1 over x minus 1. That is our answer. On to the next. All right, guys. So on the next page, we need to solve for x for these rational equations below. We have to check for extreme solutions. So here we go. So the first step is we want to factor. Notice that this is just going to be 2 minus 3 over x plus 4 is equal to 12 divided by x times x plus 4, right? So this looks pretty straightforward. The LCM for this one should be x times x plus 4. So two ways to do this. We can multiply both sides by the LCM, which is what you see on the paper solution. Or just know that, hey, I need to multiply each fraction by the missing factor, right? So that we get the LCM. So 2, this first fraction, right, it is missing, let's see, it's missing the x and x plus 4. So we should do something like 2 times x plus 4. So we're good with the first fraction. The second fraction is missing the x, so it should be 3 times x. And then the last fraction is missing, well, nothing. It's good. So we have this. Lots of stuff to clean up. You can do this first. I like to do that first. So we have 2 times x squared plus 4x. I distribute the x. Minus 3x is equal to 12. Distribute the 2. So we have 2x squared plus 8x minus 3x is equal to 12. Just move stuff around in combined terms. So 8x minus 3x is 5x. And then let's subtract the 12 at the same time. Save some space. So we have that. This is a pretty easy factorization. 2 is, well, prime. So if it does factor, it's something like this, 2x and x. 12, well, we can list out the factors of 12. 1 and 12, 2 and 6, 3 and 4, 4 and 3, 6 and 2, and 12 and 1. So like I said before, we want to avoid bad combinations. 2 and 6 is terrible because 2 and 2 has a GCF, right? So we don't want to choose that. We want to avoid 4 and 3. 4 and 3 is also a very terrible combination because 2 and 4 has a GCF of a 4. So it's likely going to be either this, not this, not this. So it's probably going to be 3 and 4. Right, so we want this to be positive, we want this to be negative. All right. So 2x times 4, that's going to be 8x. Negative 3 times x is negative 3x. You add them up, you get 5x. So we are good. Now we need to set each factor equal to 0 and then solve for x. So the first one is 2x minus 3 is 0. Add the 3, divide by 2, it's 3 over 2. The one on the right, it's pretty straightforward. X plus 4 is 0. Subtract the 4 from both sides. X is equal to negative 4. Now we need to check. So right off the bat, I know negative 4 is just a bad answer. Because if we were to check, x is equal to negative 4, right? For the OG function, the original function, if you plug it in, we get this, negative 4 plus 4. This is bad because this is undefined. So negative 4 is a terrible solution. It's extraneous. right? 3/2 should be right. 3/2 should work because as long as your denominator, look, as long as your denominator is not 4 and it's not 0, right, then it should be a solution. But let's just check it. It's kind of annoying to check, but let's just do it. Let's check when x is equal to 3/2. So if you check 3/2, it should be 2 minus 3/2 plus 4. It's equal to 12 over 2/2 squared plus 4 times 3/2. So 3/2 plus 4, that's just going to be 4 is like saying 8/2, right? So 8/2. So 4 is like saying 8/2. So 8/2 plus 3/2 is just like saying 11/2. Then this guy, this is going to be, what is this? 3/2 squared. 3/2 squared is just 9/4. And then 4 times 3 is 12. So it's 12/2, right? So 12/2 is kind of like saying you multiply by 2/2. That's like saying 24/4. Okay. So over here, it'll be 2 minus 3 times 2/11, right? Because we're multiplying by the reciprocal. And over here, it'll just be 12 divided by, what is this? 12 times 2 is 24, 33/4. So on this side, this is like saying 22/11. So 22 minus 6/11. What is that? 16/11. And this is just like saying 12 times 4/33. These two are both divisible by 3, so that's 11/4. So this is good. It'll just be 16/11 is equal to 16/11. So we did some like basic fractions are our friend technique, right? We're just like added fractions. We combine fractions by adding them together and finding like another LCM, etc. So, and it's a lot of work there, but yeah, it's true. We knew that, right? If we solved it correctly, it would have been the solution. Right. Okay, so that's that. So we are good. So let's try the next one. Let's do this one in blue now. So this one, the LCM should just be x minus 1, right? LCM is pretty straightforward here. LCM is x minus 1. So first fraction, we're good. So it's just 2 plus. Second fraction is missing the x minus 1. And the last one is also missing the x minus 1. So you multiply out the x. So it's going to be 2 plus x squared minus x is equal to 5x minus 5. Let's see. I'm going to switch this around a bit. I'm going to put the 2 over here. So it'll be x squared minus x plus 2. And at the same time, I want to move this over to the left side. So I subtract the 5x and I add the 5. And then I combine like terms. So it'll be x squared minus 6x because negative x minus 5x is negative 6x. And 2 plus 5 is 7. So this one doesn't factor because it looks like it factors, right? Because it looks like it's like 7 and 1 somehow. But the issue is this is negative 1x and this is negative 7x and this is just negative 8x. That's not what we want. We want the negative 6x. So unfortunately, this doesn't factor. So we have to use the handy dandy quadratic formula. So the quadratic formula will be given to you. It is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 6, and c is equal to 7, right? So x is going to be negative 6, which is positive 6, plus or minus the square root of b squared, which is negative 6 squared, minus 4 times a, which is 1 times c, which is 7, all over 2 times 1. So x is going to be negative 6 is 6, plus or minus, square root. Negative 6 squared is a positive 36. What is that? Minus 28, all over 2. So this is just going to become 6 plus or minus root 8 over 2. Now, keep in mind, so if you look at the paper solution, it kind of skips steps and you get like 3 plus root 2. And the reason why that works is because the square root of 8 is like saying the square root of 4 times 2. If you split that up, it'll be square root of 4 times the square root of 2. And we know that the square root of 4 is 2. And the reason why we split that up like that is because 4 is a perfect square, right? But 4 is also a factor of 8. So you'll see that the answer is going to be 6 plus or minus root 2 over 2 over 2. And if you split that up, right, 6 divided by 2 is 3. And then, so essentially these cancel out. So it'll just be 3 plus or minus root 2. Those are your answers. So the annoying part is checking to make sure that they're not extraneous. They're not, because as long as x is not equal to 1, you are good. So these are not extraneous. But to check it all out, I'll check one of them. X is equal to 3 plus root 2. Right? It would just be 2 over 3 plus root 2 minus 1 plus 3 plus root 2 is equal to 5. All right, so the bottom one is going to become 2 over root 2 minus, oh no, plus 2, right? So it's root 2 plus 2 plus 3 plus root 2 is equal to 5. So the best way to do this, like to clean it up, is to multiply both sides by the you need to multiply by the reciprocal to conjugate. So we kind of want to either like, we want to multiply both sides by 2 minus root 2, which is kind of annoying. I'm trying to think of like a fast way of doing this. All right, guys, so let's check if these are solutions. So the first check we want to do is to check if x is equal to 3 plus root 2 is a solution. So we take that answer and we plug it back in for x. So all I'm going to do is replace it. So 3 minus 1 is 2. So this is just like saying 2 plus root 2 plus 3 plus root 2 is equal to 5. Okay, so a couple of things. Lots of ways to do this, but quickest way is, what's the LCM? The LCM should be 2 plus root 2, right? So first fraction is fine, so that leave it by itself. Second fraction should be 3 plus root 2 times 2 plus root 2 is equal to 5 times, not a lot of space here, fix that up. It should be 2 plus 3 plus root 2 times 2 plus the square root of 2 is equal to 5 times 2 plus root 2. Okay, so that's going to be 2 plus 3 times 2 is 6. 3 times root 2 is just 3 root 2 plus 2 root 2 plus root 2 times root 2, which is like saying root 2 squared, which is 2. So that's going to be 5 times 2 is 10 plus 5 root 2. Let's see if that's right. 6 plus 2 plus 2 is 10. 3 plus 2 is 5. So it's going to be 10 plus 5 root 2 is equal to 10 plus 5 root 2. All right, so that's that. Let's check the other one. I'll do this in red now. We'll check the one that is check x is equal to 3 minus root 2. You plug it back in, it's the same stuff. It's just going to be 3 minus root 2. So 3 minus 1 is just 2 minus root 2 plus 3 minus root 2, which is equal to 5. Do the same process. So the LCM is 2 minus root 2. It's just 2 plus 3 minus root 2 times 2 minus root 2 is equal to 5 times 2 minus root 2. So that's going to be 2 plus 3 times 2 is 5. This time we have negative 3 minus 2, which is negative 5 root 2. And then negative root 2 times negative root 2 is positive 2. So this is just 10 minus 5 root 2. 3 times 2 is 6. Made a mistake there. So 2 plus 6 plus 2 is 10. Minus 5 root 2 is equal to 10 minus 5 root 2. And it works. And so these are not extraneous. And we're done. Alright guys, so we are going to solve the rational inequalities on the last page. So the first thing that we want to do is we want to factor this. So in the numerator, we're looking for two numbers that multiply to get negative 10 that adds up to 3. It has to be 5 and 2. So it's going to be x minus 5 plus or minus 5 or plus or minus 2. So you want it to be positive 3. So the 5 should be larger. And then for our denominator, right, we want two numbers that multiply to get 9 and adds up to negative 6. So it has to be like 3 and 3. And we want it so it's less than 0. So here we have, let's see, how many critical values do we have? We have 4 technically, right? But 2 of them repeats. So critical values, right? We have x is equal to negative 5, 2, and 3. 3 repeats. So I want to make a number line. Negative 5, 2, and 3. And we want to plug in some test values. So let's plug in like 4, right? If I plug in 4 plus 5 times 4 minus 2 over 4 minus 3 times 4 minus 3. 4 plus 5 is 9, which is positive. 4 minus 2 is positive. 4 minus 3 is positive. And 4 minus 3 is positive. So this is going to be positive, right? We know that between 2 and 3, this is also going to be positive because 3 repeats. If it doesn't repeat, then it should alternate. So this should be negative. This should be positive. So I don't like to waste my time. You could plug in more values, say 2.5. You can plug in like 0. You can plug in like negative 6. But that's all I did. We want to check to make sure that it's negative. Less than 0 means negative. So we want to shade in the regions that are negative, right? So it's only negative here. And because this sign is a less than symbol, right? We know that all of these circles are going to be open. So our answer is pretty straightforward. It's negative 5 to 2. negative 5 to 2, and they're both parentheses because they're open circles. All right, so for the next one, we need to do the same process. We need to factor. So the top one is straightforward. It would just be x plus 1 times x plus 2. And the bottom should just be x plus 4 times x minus 4. This is greater than or equal to 0. So my 4 critical values should be x is equal to negative 1, negative 2, negative 4, and 4. So let's make a sign chart. Are 1, 2, 3, 4. Negative 4 is the smallest, then negative 2, then negative 1, then 4. So a couple things I've noticed here. There's an equal to symbol, and this is greater than. So greater than means it's positive. We want positive values, or it's equal to 0. So it can only be equal to 0 if the critical values are in the numerator, right? So that means that this is equal to 0, and this is equal to 0, right? So these are what we call like open circles. Open circles. They're defined, right? Or sorry, they're closed. My bad. These are closed circles. They're closed, right? Because they're defined. Our denominator, right, cannot be 0. So when we plug in like negative 4 and 4, right, it's undefined. It's undefined, right? So at negative 1, negative 2, those will be closed. Then at negative 4 and 4, they will be open, right? So let's plug in some test values. I like to plug in like 10 or some large. So 10 plus 1, 10 plus 2 over 10 plus 4 times 10 minus 4. 10 plus 1 is positive. 10 plus 2 is 12, which is positive. 10 plus 4 is 14, which is positive. And 10 minus 4 is positive. So we know that a positive times positive is a positive, divided by a positive, which is a positive. There's no repeating factors, so this one is straightforward. It's just positive, negative, and positive. And what did we wanted? We wanted the positives. So we shade in this area, and this area. Here, here, here. So our solution, right, should be negative infinity to negative 4, parentheses, union, negative 2 to negative 1, square brackets, union, 4 to infinity. And we are done.